So the question arises, what is necessary to really create such a digital twin? And there are several steps we have to take. And one of them is to implement, let's say, digitalized workflows and to really come to what we were talking before. So how do I get the data, the information, the links for the data spaces I have, which are my basis for my digital twin? And normally, when we look at these things, we have a distribution of simulation people, of experimental people, and so on. And that really is evolving in a different way at the moment. So we don't care that much anymore where the simulation, if it's simulation data or if it's an experimental data or if the data comes from an inline sensor. The reason is it's all data. The most important thing when we use the data, it has different qualities, it has different reliability, accuracy or uncertainties, and we need to know them and transport them with the materials data. In the end, this step of generating data is then independent of where it comes from if it's including the information I really need to run the digital twin. Then I would take that data, and one of the ways of saving it is also the question. We're working on different ways of storing the data because at the moment we're looking at data as columns and in a spreadsheet or something like this, like in a database. In reality, it's heavily interconnected. And one of the ways of looking at it more on a physical basis is introducing ontologies which are describing the interaction, for example, between an object like a sample, a process like a tensile test, or if I form a sheet metal or anything like that. And if I can really describe what happened to the material, to give it a history and store that into a way that I can interpret it in the continuous steps to where I want to predict what the material does in the next step. So if I have it stored in a way, then I would take it and pre-process that information. And that can be, for example, as shown here, like a tensile test. I'm pulling on a sample, it's stiff at the beginning, and then I see plastic deformation, and I can plot that easily because I take my raw data from where I stored it. I run a script, which I always use. It's reproducible, I can understand how it works, and then I get my information, and the interpretation of what that means for my application is then the last step, and that's this data analytics, or let's say also the prediction of how that affects my application in the end. So that means that we can predict what happens inside of that application, and that's again based on this more or less holistic view on the material in a completely digitalized form, which is then fed by these workflows, these digital workflows, which are underneath, and they are giving me the base for that digital twin.